This is SpaceTime Series 25, Episode 114, for broadcast on the 26th of October 2022. Coming up on SpaceTime, astronomers have now discovered over 30,000 near-Earth asteroids, NASA's Lucy spacecraft swoops past the Earth, and Russia launches a new top-secret spy satellite as it continues its war in Ukraine. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart-Gary.
Okay, let's take a break from our show for a word from our sponsor, NordVPN. I don't need to tell you that we think NordVPN is simply the best virtual private network in the world. And it's not because they're a sponsor of ours. We were using NordVPN long before they came on board, because when we weighed up all the different options available, they really were the best. They provide a wide range of security features, including high-level encryption, DNS leak protection, and kill switch technology. They offer unlimited data transfer, 24/7 customer support, and a 30-day money-back guarantee. And they also have a no-logging policy. For a journalist, that's great because it means you can safely talk to secret sources. And it's great for you too, because it means there are no IP address logs, no connection logs, no DNS requests, no browser history, no app usage, and no server logs. So that means there's no record of your online activities stored anywhere. Also, NordVPN has no limits on bandwidth or speed, and it will allow you to connect up to 6 devices at once. It's just a really good, carefully thought out all-round package, and that's why we're proud to recommend it. You really should visit NordVPN today. Just go to nordvpn.com/StuartGary to see even more reasons why you really should get connected. And while there, click on the Get the Deal button to access our special SpaceTime deal. It's an amazing offer, 69% off on a 2-year plan with bonuses. And that URL again is nordvpn.com/StuartGary to get your 69% off on a 2-year deal with bonuses. And of course, as always, we'll have the URL details in the show notes and on our website. And now, it's back to our show.
This is SpaceTime with Stuart-Gary.
Astronomers have reached a major milestone with the discovery of their 30,000th near-Earth asteroid. As of last count, the European Space Agency is reporting that astronomers have now discovered more than 30,039 near-Earth asteroids circling the Sun on orbits that bring each of them within 45 million kilometres of the Earth. Asteroids have been catalogued by astronomers for more than 2 centuries, ever since the very first series was discovered back in 1801 by Giuseppe Piazzi. The first near-Earth asteroid, 433 Eros, was discovered nearly 100 years later on August 13, 1898. The roughly 30-kilometre wide Eros is on an orbit which brings it to within 22 million kilometres of the Earth. Naturally, large asteroids were discovered first, as they're a lot easier to see. They were thought of as minor planets, a term still used today. And as telescopes got more sensitive, astronomers began finding more and more asteroids and lots of smaller ones. Ground-based survey telescopes, like the Catalina Sky Survey in Arizona, are now discovering on average 1 new asteroid every week. These survey telescopes are designed to scan large areas of the sky, looking for new objects moving in front of the background of motionless stars. More focused large telescopes, such as the European Southern Observatory's Very Large Telescope, the VLT, can then be used for follow-up observations, helping astronomers better understand a new asteroid's path, size, and even composition. The European Space Agency's Gaia spacecraft, on a mission to catalogue some 1 billion stars in our galaxy, has also helped scientists better understand the asteroid risk. New objects are observed over time. Their movements are studied, and with just a handful of data points from different nights of observation, their future positions can be predicted reasonably reliably. Depending on the number and quality of observations, this can extend decades, even hundreds of years into the future. ESA's Near-Earth Object Coordination Centre at Istra in Italy is home to the agency's asteroid experts and risk assessors. The team activates a network of telescopes around the globe, getting observations of newly discovered asteroids in order to determine their risk of impact with the Earth, while also chasing up older asteroids yet to be deemed safe. Disturbingly, there are currently some 1,425 asteroids with a non-zero chance of impacting the Earth. They're organised into an asteroid risk list, which is constantly being updated. While small asteroids less than a metre in size often do impact the Earth, they usually end up burning up in the atmosphere. When it comes to large and potentially devastating asteroids, those more than a kilometre across, the majority are large enough to have been discovered by now, and none of them show an impact risk with the Earth for at least the next century. For those that could impact later, astronomers still have plenty of time to study them and prepare a deflection mission. The current priority for astronomers are the medium-sized asteroids, those a few hundred metres in diameter, many of which have yet to be discovered, hiding out there in the blackness of space. Their size makes them difficult to spot, and if they're coming from the direction of the Sun, virtually impossible to see in the Sun's glare. Asteroids this size aren't big enough to destroy a continent, but they are big enough to wipe out a city. This is SpaceTime. Still to come, NASA's Lucy mission swoops past the Earth on its way to Jupiter, and Firefly's new Alpha rocket reaches orbit for the first time. All that and more still to come on SpaceTime. NASA's Lucy spacecraft, the first mission to the Jupiter Trojan asteroids, has just undertaken a spectacular gravity-assist flyby of the Earth, skimming the planet's atmosphere and passing a mere 350 kilometres above the surface. That's lower than the orbit of the International Space Station. By slingshotting past the Earth, Lucy will gain some of the orbital energy it needs to eventually fling itself out to the location of the Jovian Trojans. Jupiter's Trojan asteroids are trapped in orbits around the Sun at the same distance as Jupiter, moving either 60 degrees in front or 60 degrees behind the gas giant. Lucy is currently 1 year into a 12-year mission to explore these objects. This gravity assist will place Lucy on a new trajectory for a 2-year orbit, at which time it will return to Earth for a second gravity assist flyby. That second flyby will give Lucy the energy it needs to finally cross the main asteroid belt, where it will observe the asteroid Donald Johanson and then travel on to the leading Jovian Trojan asteroid swarm. There, Lucy will pass 6 Trojan asteroids: Euripides and its satellite Quita, Polymele and its unnamed moonlet, as well as Lucius and Orus. Lucy will then return to Earth for a third gravity assist flyby in 2030. That'll redirect the spacecraft for a rendezvous with the Patroclus-Menoetius binary asteroid pair located in Jupiter's trailing Trojan asteroid swarm. This report from NASA TV.
The Lucy mission is going to fly past 7 asteroids in 12 years with 1 spacecraft.
We are going to an amazing variety of objects with this mission. And it's really almost pure luck that allowed us to get as many rich targets as we are. Literally, the planets were aligning to allow us to do this mission.
The Lucy mission is named after the Lucy fossil, the Australopithecus fossil that was discovered in the 1970s in Ethiopia. And just like the Lucy fossil transformed our understanding of hominid evolution, the Lucy mission will transform our understanding of solar system evolution.
Trojan asteroids are an interesting population of small bodies that are left over from the formation of the planets, and they lead or follow Jupiter in its orbit by roughly 60 degrees. If you just look at the gravitational attraction of the Sun and Jupiter and put something exactly 60 degrees in front of Jupiter, it's stable forever. So as a result, these objects are really the leftovers of planet formation. The stuff that went into growing Jupiter and Saturn are now trapped in these locations.
The very first asteroid we get to is a main belt asteroid named Donald Johanson. We named that asteroid in honor of the researcher who found the Lucy fossil. We're going to use that asteroid to do a rehearsal on our spacecraft to make sure everything is working properly so that when we get to the Trojan asteroids, we're ready to go.
We're visiting both of the Trojan swarms. In the first orbit, we're going into the leading swarm, and we're going to encounter Trojan targets.
And from this, we're going to sample the diversity in sizes and colors and compositions. The first two flybys happen just about 30 days apart, so it's going to be a pretty busy kickoff to the season of exploring the asteroids in the L4 swarm. And then we'll fly past Earth again and out to the L5 swarm.
The final object we're visiting, which I must admit is my favorite, is a binary object.
So that's two Trojans that orbit a common center of mass. It's called Patroclus and Menecius.
These objects are nearly identical in size that orbit one another.
From the Lucy mission, we're going to study the diversity of our targets because that tells us something about their origin and where they came from.
The interesting thing about small bodies in general is they are the leftovers of planet formation. If you look at the 8 planets that we know about, for example, they are highly processed because of internal processing. These asteroids are objects that really haven't changed much from when the planets assembled themselves. And as a result, by studying them, we can figure out the physical conditions of the early solar system, as well as how the planets grew and how they moved around early on.
All of that will help us form a detailed picture of what these objects really look like. Because right now, our best images are just a point of light. Even using the Hubble Space Telescope or adaptive optics on large ground-based telescopes, we can't see surface details. And it's going to take the Lucy mission to go to these targets and see what they're really made of and what they look like.
And in that report from NASA TV, we heard from Lucy Principal Investigator Hal Leveson and Deputy Principal Investigator Kathy Alkin, both from the Southwest Research Institute in Boulder, Colorado. For its first gravity assist, Lucy approached Earth from the direction of the Sun. This meant people couldn't see Lucy in the days before its close encounter, but it allowed the spacecraft to take some stunning images of the nearly full Earth and Moon. Mission managers will use these images to help calibrate Lucy's instruments. As well as avoiding potential collisions with Earth-orbiting spacecraft and junk surrounding our planet, mission managers also had to prepare for a degree of atmospheric drag. Lucy Project Manager Rich Burns from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says the original plan was to fly some 60 kilometers closer to the Earth's surface. However, when it became clear that the spacecraft's solar arrays would be affected by flying by at that height, it was decided to use a bit of the probe's spare fuel reserves so that the spacecraft passes the Earth at a slightly higher altitude, thereby reducing disturbance from atmospheric drag on the spacecraft's solar arrays. For those on the ground, Lucy was visible to observers in Western Australia for about 7 minutes before disappearing into the Earth's shadow and then briefly reappearing in the morning light as it flew over the western United States. Lucy then rapidly receded from Earth's vicinity, passing the Moon and taking a few more calibration images before continuing on its interplanetary mission. This is SpaceTime. Still to come, Firefly's new Alpha rocket reaches orbit for the first time, Russia launches a new spy satellite. And later in the science report, Boston University rejects claims that it's created a new, more deadly strain of COVID-19. All that and more still to come on SpaceTime. Firefly Aerospace's new Alpha rocket has achieved orbit on its second launch attempt. The 29-meter tall two-stage rocket was launched from the Vandenberg Space Force Base in California. The new launch is designed to carry payloads up to 1,170 kilograms into low Earth orbit. Alpha's first launch attempt back in September last year, also from Vandenberg, ended in failure when one of the rocket's 4 first-stage engines shut down prematurely. With the second launch attempt, the rocket's first stage achieved MECO, or main engine cutoff, separating about 2.5 minutes into the flight. The upper stage then took over, inserting itself and its payload into an elliptical transfer orbit 7.5 minutes into the mission. Then about 53 minutes after the launch, the upper stage performed a brief circularization burn maneuver, placing itself into a 300-kilometer high orbit. All 3 payloads aboard the spacecraft were deployed just under an hour after liftoff. These included NASA's TESS-15 CubeSat, which features an exobrake that's designed to help satellites leave orbit more smoothly when their mission's completed. TESS-15 also carried an experiment designed to optimize data transfer from the spacecraft. The launch had originally been slated to fly 3 weeks earlier, but was scrubbed due to an unexpected drop in helium pressure. Then unfavourable weather forecasts pushed the mission back again, this time to the end of September, when it was aborted again just after engine ignition, delaying the launch once again. The Kremlin has launched a classified military satellite from its Plesetsk Cosmodrome, 800 kilometres north of Moscow, aboard an Angara 1.2 rocket. The 150-kilogram MK3 was placed into a sun-synchronous orbit. The MK are thought to be a series of optical reconnaissance satellites. The first MK was launched back in 2018, spending about 3 years in orbit before falling back to Earth in 2021. A second reached orbit dead, falling back to Earth in October 2021. And a third was launched in April this year, but fell out of the sky the following month. So far, this latest launch appears to be successful. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. Boston University has rejected claims that it's created a new, more deadly strain of COVID-19 with an 80% kill rate. The university says its research is designed to compare the spike proteins on the SARS-CoV-2 Omicron BA.1 variant with the original Wuhan strain from China. Scientists wanted to find out if the virus was truly less virulent because it wasn't infecting the same cells as the initial strain. The university also rejected claims that the work was gain-of-function research, which was the primary allegation against the original SARS-CoV-2 research carried out by the Wuhan Institute of Virology and partly funded by America's National Institute of Health, of which White House Chief Medical Advisor Dr. Anthony Fauci, yes, that one, is the director. A university spokesperson says that consistent with studies published by others, this work shows that it's not the spike protein which drives Omicron pathogenicity, but instead other viral proteins, and determination of these proteins will lead to better diagnoses and disease management strategies. New revised figures show almost 6.6 million people have now been killed by the COVID-19 coronavirus since it was first detected near China's Wuhan Institute of Virology around September 2019. However, the World Health Organization says the true death toll is likely to be over 15 million, with some 632 million confirmed cases globally, while the Lancet Commission, a panel of world-leading experts in policy and disease management, estimates around 18 million people have now died because of COVID-19. A new study has found that the Indian Ocean dipole, one of the key drivers of Australia's climate, has become more influential since the 1990s, severely reducing wheat yields for Australian farmers. The findings, reported in the journal Nature, are based on new computer simulations and artificial intelligence algorithms which investigated what's been happening to the Indian Ocean dipole since the 1990s and changes in Australia's other major climate driver, the El Niño Southern Oscillation. They found that the impact of the El Niño Southern Oscillation has actually been decreasing since the 1990s, but those from the Indian Ocean dipole have been increasing. The increase in positive Indian Ocean dipole events is a result of global warming, and that's led to a big reduction in wheat yields for Australian farmers over the past 30 years. The findings highlight the need to adapt seasonal forecasting to the changing situation as climate change worsens to help farmers mitigate yield losses. A new study warns that older people who sleep less are more likely to die early. The findings, reported in the journal PLOS Medicine, found that adults over 50 who sleep for 5 hours or less per night have a greater risk of developing more than one chronic disease compared to their peers who sleep 7 hours. Scientists looked at data from 7,864 healthy participants starting in 1985, which included self-reported sleep duration at age 50, 60 and 70. They found people who reported sleeping 5 hours or less at age 50 had a 30% greater risk of developing a wide range of chronic health issues termed multimorbidity and a 25% greater risk of dying prematurely compared to those who slept for 7 hours. At age 60, those who slept 5 hours or less had a 32% greater risk of multimorbidity, and at 70, a 40% greater risk compared to the 7-hour sleepers. The findings highlight the importance of sleep duration for good health in older age. It's that time of the year again when the big tech companies roll out their new toys in time for Christmas, and Google are among them, showing off their latest Pixel smartphones, as well as a new smartwatch, and they've also provided a sneak peek of their plans for a new tablet. With the details, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
Well, these are Google's new flagship phones for late 2022, the Pixel 7 and 7 Pro. The Pixel 7 is the 6.3-inch screen with 90 hertz display, so it's not as smooth as the 120 hertz. It's priced in Australia at $999 for the 128 gig model. Then there's the Pixel 7 Pro. That one's $1,299. You can actually pay more to get that in a 512 gig configuration. It's got better cameras. It's got a 6.7-inch screen. It's got the 120 hertz refresh, so it's nice and smooth. Both of them have the Google Tensor G2 chip, which is their Google's all-singing, all-dancing chip with all sorts of neural and other smarts inside. They're promising proper all-day battery life, and then there's this extreme battery mode. So they're Google smartest phones. They've got more AI smarts inside of them. Google has a range of its own Pixel exclusive features. You can unblur a photo now in the Photos app, even if it's one you've taken 10 or 15 years ago. There's a new cinematic mode. There's better selfie modes. There's new zoom modes on the Pixel 7 Pro. They're able to crop part of the image to get a 2 times or a 10 times, for example, which is not as good as having a dedicated 10 times lens, but still delivers sharper shots than they could do before. And they're pairing this with a Pixel Watch. It's sort of like their first version of their latest Android Wear OS 3 watch with Fitbit. They bought Fitbit. And for a first attempt, I mean, obviously it's been years of Android Wear watches before, but for this first new one, they've done pretty well. The screen size is a little bit small. The bezel around it is a little bit big, but it's managed to sort of hide it. It looks very beautiful. I do see that the square screen of the Apple Watch does stop text from being cut off on the side, which is something you have to do with a circular screen. But it also has that proper watch aesthetic. Although I did see the Apple Watch Ultra today, and that's quite a beast. I'm imagining that there's a Pixel Watch Pro in the work, and I'm sure the screen next year will be bigger. There's also a tablet coming in 2023 that sits on a dock. It's a bit like the Google Nest Hub docks I have now, or one of the Amazon Alexas. You see this base, and there's a screen on top. Well, imagine if you could take the screen away, and that was your tablet, like an Android tablet, an iPad, a Galaxy tablet. Imagine if you could just do that. Well, Apple's supposed to be working on one of those as well to come out sometime later this year. But I do recommend you go to youtube.com/made by Google. There's some great keynotes there from the past and the most recent one, plus other feature videos showcasing all the cool stuff the new phones can do. They even joked that they had crash detection 3 years ago. Apple just launched it with the iPhone 14 and 14 Pro. So prices are keen. They want to get more of the market share. I mean, all the other brands sell a lot more of their phones than Google sells of its Pixels, but these are its best ones yet, which is what you say every year. But they truly are the best ones. There are a few bugs. People have noticed them. One of the updates came out, fixed some of them. There was a lot of bugs with the Pixel 6 and 6 Pro. Took them 3 or 4 months to fix by some reckoning. So hopefully they're much quicker on the mark this time.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTime-with-stuart-gary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTimeWithStuartGary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.